In this lesson video, we're going to be starting Chapter 8, which is all about polynomials. We're going to be, in Chapter 8, we're going to be adding, subtracting, multiplying, factoring, doing a whole bunch of stuff with polynomials. So today we're going to start in this lesson video 8.1 with adding and subtracting, okay? So first of all, what is a polynomial, right? A polynomial is a monomial or a sum of monomials. And then it goes into further detail. So what does that mean? What is a monomial? Well, mono means one, right? Mono. And the nomial part, I guess I don't know, they're combining it. The nomial part is just talking about terms, or I guess numbers, I'm not really sure. Mono means one, and then it gets further. So bi means two, tri means three. We'll get further into that. So what is a monomial? I wrote it down here. Here's some examples. So if I have the number 4, that's one term, right? One term. Terms are separated by plus and minus signs. That's one term. So that's a monomial. Just one term. Okay, what about 4x? Same thing, one term. There's no plus or minus sign, so it's still one term. This is a monomial. What about 4xy squared? Still a monomial. There's no plus or minus signs. It's just one term. Then what if I have 4xy squared plus z? Now I've got two terms. This plus sign separates my two terms. So this is a binomial. This is an equation or an expression that contains more than one term, like one unit. One unit is just all these together when they're multiplied together. And it could be down to just a single number. But once we start adding in plus signs or minus signs, then we've created more than one term. So here in this case, we have 2. That's a binomial. 4xy squared plus zy to the fourth. Again, another binomial. This guy right here, 4xy squared plus zy to the fourth minus x to the sixth power. This is 1, 2, 3 terms separated by a plus and a minus sign. So this is a trinomial. Trinomial. Sounds like we're saying trinomial, like we're emphasizing the meal part. It's not. You're emphasizing the first part, trinomial. You're just saying nomial real fast at the end. And then lastly, we have this guy here, 4xy squared plus zy to the fourth minus a fraction. So whenever you have a term, I guess, whatever, on the bottom of a fraction, if it's division, anytime we're using division, that is not a monomial. And you have to have monomials to make up a polynomial. Polynomial is just made up of many monomials. That's what the poly is for, many. So here, this is nothing. So whenever you see this fraction here, this is not... Now, if it was a number like 1/2, 1/2, that's a term because we could change it to a decimal, fine. But a variable divided by another variable, we can't change this to a decimal. It's something different. So when you have a variable on the bottom of a fraction, that is not a monomial. So this is not a polynomial. This is nothing. Put a big X here, okay? The next thing we're going to talk about, I'll go back to the worksheet in just a second, is the degree of each monomial, okay? The degree is basically the exponent. How high does the exponent go? So what you're going to do is add up the exponents of all variables in each term, okay? So what does that mean? Well, here, there is no variable, right? So I want you to think of this as, okay, there is a variable, but the exponent is 0, right? Remember, anything to the 0 power is just 1. So this is like saying 4 times 1, which is just 4, right? So the highest exponent of any variable here is 0. So the degree is 0. So basically, when you have no exponents, the degree is 0, okay? Here we have an exponent. And when an exponent. When you have no variables, the degree is 0. Here we have a variable. We don't see an exponent, so we know that it's a 1, and we don't have to write the 1 when that's the exponent. So the highest exponent of any variable in this term is 1. So here the degree is 1. Here, now we've got a couple variables, right? And it's still all one term. It's a monomial. It's It's one term. So we're going to add up all the exponents of the variables in one term. So this is x to the 1 power. This is y squared. 1 plus 2 is 3. So the degree of that term is 3. I hope that's making sense, okay? Here, I've got 4xy squared. We know the degree here is 3 of this term. And then I've got this guy. This is a separate term. So how do I know what the degree of this whole thing is? Basically, you find the degree of each term and just pick the biggest one. I know that's a weird rule, but you just pick the biggest one. So this degree is 3. This degree is just 1. So what's bigger, 3 or 1? 3, right? So the degree of this whole polynomial is just 3. So anytime you're finding the degree of a polynomial, you have to find the degree of each term by just adding together the exponents of the variables in each term. And if there's more than one term, you just find the degree of each term and pick the biggest one. Okay, here we have 4xy squared. We know the degree of this is 3. It hasn't changed. And then we have zy to the 4th. So the z has an exponent of 1. 1 plus 4 is 5. So now this degree is 5, this degree is 3. Which one's bigger? 5, yeah. So the degree of this whole thing is 5. And we don't count the 4. Remember at the very top, the 4 doesn't have an exponent. So the degree of just a plain number is always 0. We think of it as, okay, there really is an exponent there, but it just has, sorry, I keep saying exponent. There really is a variable here, but it has an exponent of 0, which just makes the whole thing 1. Okay, so we found this degree is 3, this degree is 5. 5 is the biggest, so the degree of the whole thing is 5. Don't add them together, just pick the biggest one. Here, 3, zy to the 4th, that degree of this thing is 5. And then we have minus x to the 6th. That has the biggest degree, it's 6. So we have 3, 5, and 6. The biggest degree of any of the 3 terms here is 6, so the degree of the whole thing is 6. I hope that's making sense. And then we said that for this last one, when you divide, I know that you could technically change this to x to the 6 times y to the negative 2. You could totally do that, but we can't use negative exponents. If it's got a negative exponent, it is not a monomial. Right? It's an exception. And we have to have monomials to create a polynomial. We can't take the degree of anything that's not a monomial. So since this isn't a monomial, there is no degree. There's just nothing. You just wouldn't answer that question. Okay, so I hope that's making sense. Let's go back to the worksheet. All right, so they gave you this little table. This file is here below the video in this folder, so you can pull it up if I'm going too fast. The terms of a polynomial, which is just a bunch of monomials added together, are usually arranged so that the terms are in order from greatest to least, left to right. This is called standard form, right? So if I had x to the 3rd minus 2y squared plus z. This is in standard form because this term has the biggest degree, then this one has the next biggest, and then this one on the far right is the smallest. It goes biggest to smallest, standard form. All right, determine whether each expression is a polynomial, and if so, identify it as a monomial, a binomial, or a trinomial, and then find the degree of the polynomial. So for this first one here, 3x minus 7xyz. Okay, well, there are 2 terms here. They're separated by this minus sign. Let me zoom in a little bit. Okay, the degree of the first term is 1, right? X to the 1 power. The degree of the second term, each of these variables has a 1 exponent. A 1 here, a 1 here, a 1 here. So that's a degree of 3. So this is a binomial because it has 2, here I can separate them with a highlighter, 2 terms separated by a minus sign. And then out of those 2 terms, the largest degree is 3. So the degree of the whole thing is 3. Binomial, degree of 3. Okay, next one, negative 25. This is a monomial. It only has 1 term. There are no variables, so when there's no variables, the degree is 0. So it's a monomial, and the degree is 0. Next one, here we have 7n to the third plus 3n to the negative 4. Remember, you can't have negative numbers because really that means this n, we write it like 3 over n to the fourth, and you can't have a variable on the bottom of any fraction. Shows you here. So this is nothing. So we just say none of these. You can't qualify it. It's nothing. There is no degree. So we just leave that part blank. It's not a polynomial. And then lastly here, we can actually simplify this and combine like terms. So we've got 9x to the third. We can combine 4x plus 2x, and that's 7x. So 9x to the third plus 7x, and then we still have this 4 we can tack on to the end. This is in standard form, biggest degree, next biggest degree 1, and then this has a degree of 0, so biggest to smallest. And there are 3 terms here separated by plus signs. 1, 2, 3. So this is a trinomial. And the greatest degree here out of 3, 1, and 0 is 3. So it has a degree of 3. I hope that's making sense to you guys. Let me know if you have questions. You can always go back and replay the video. All right, so let's do some exercises on our own. The directions say to determine each expression, whether each expression is a polynomial, and if it is, we have to find the degree and tell whether it's a monomial, a binomial, or a trinomial. So I'm going to zoom in here a little bit. Okay, so this first one, this is one term. There's no variable here, so the degree is 0. So this is a monomial. Has a degree of 0. And I think that's all we had to do. Is it a polynomial? Oh, and we had to say yes, it's a polynomial. Yes, it's a polynomial. It's a monomial, and it has a degree of 0. This guy. Is this a polynomial? Nope, because you can't have a variable on the bottom of a fraction. So because of this, this is not a polynomial. Okay, number 3. 7x minus x plus 5. We need to simplify this first off. We can combine these two. 7x minus x is 6x plus 5. Remember, you can't combine terms if they don't have the same variable with the same exponent. So if this was x squared and this was x, I couldn't subtract them. Since they both have an x and both x's have the same exponent, then I can combine them. Okay, so here's my simplified polynomial. It's got 2 terms, so this is a binomial. It is a polynomial, it's a binomial. Binomial, and it has a degree of what? This has a degree of 0 because there's no variables. This has a variable with an exponent of 1, so it has a degree of 1. Just write 1 at the end. I'm going to say, is it a polynomial, yes or no? What kind is it? And what's the degree? Number 4, is this a polynomial? Well, I don't see any variables in the bottom, so yes, it is. So we're going to say yes. What kind is it? Well, I've got 3 terms here, right? I've got this guy, and then a minus sign, and then this guy, and then a plus sign, and then this guy. So this is 3 terms. That's a trinomial. And what's the degree? Well, the degree here, this is 2, this is 1, so that's a degree of 3. This G is 1, this H is a 1, that's a degree of 2. And this 2 is nothing, it's just a degree of 0. So out of 3, 2, and 0, 3 is the biggest. So we have a degree of 3. And if it's written in standard form, does it say these are all written in standard? It doesn't say that they're written in standard form. But when you write polynomials, you will always write them in standard form. So the largest term, the term with the largest degree will always be the first one here on the left. Couple more. Number 5, is this a polynomial? No, because we've got a variable on the bottom of a fraction. So nope, not a polynomial. You don't even have to keep going. Just once you see that in the bottom of a fraction, it's not. All right, here, is this a polynomial? Yes, it is. There's no variables underneath fractions. In the bottom of fractions. We've got an x and an x squared. Can I add these together? Nope. You can't add or subtract if they have different exponents. So this is two terms separated by a plus sign. I can't simplify anything. So this is a binomial. And this has a degree of 1. This has a degree of 2. Out of 1 and 2, 2 is the biggest. So the degree of the whole thing is 2. Hope that's making sense. We're just kind of classifying them. All right, next part. Write each polynomial in standard form and then identify the leading coefficient. All right, so here, can I combine any of these? Can I combine 3, 5, and 2? No, they're all x's. They have the same base, but they all have different exponents. So I can't simplify anything, but I do need to write them in order, biggest degree to smallest degree. So out of 3, 5, and 2, 5 is the biggest, so I'm going to write x to the 5th. Used it. Out of 3 and 2, 3 is the biggest, and it's positive x to the 3rd, so plus x to the 3rd. And then the smallest is 2, and this is a negative x squared, so minus x squared. Okay, and what is the leading coefficient here? Out of this whole entire polynomial, what number is in the very front? 1, right? When I don't see a number, it's a 1. If it was a 0, 0 times x to the 5th would be 0, and x to the 5th would go away. So for this to even be here, there has to be a 1 in front of it. We just don't write the 1. So I'm going to say leading coefficient equals 1. Okay, so we're just putting them in standard form and then telling the leading coefficient. All right, I've got x's, I've got a 4, a 3, a 5, and nothing. So I can't simplify this at all, but I can put it in standard form. The biggest exponent here is this 5. So this whole term is negative 7x to the 5th. The next biggest I have is 4, so positive x to the 4th. Then I have an x to the 3rd, so plus 4x to the 3rd. And then lastly, I have this 1. Okay, so here's my polynomial in standard form, biggest to smallest in exponents. And the leading coefficient here is a negative 7. So LC, there is no rule about that you can't have a negative in front. That's fine. We're just identifying what it is right now, so negative 7. Okay, number 9. I'm running out of space. A 6, a 5, and an 8. So I want to put them in order. The 8's the biggest, so I'm going to put 2x to the 8th first. And then I've got a 6 and a 5. The 6 is the biggest, so I'll put this guy next. It's negative 3x to the 6th. And then lastly, I have negative x to the 5th. Make sure the sign in front of each term stays in front of each term. Okay, so I've got 8, 6, and 5. Sounds good. These negative signs do not affect the exponents. They only affect the number in front of each variable. So this is a positive 2, this is a negative 3, this is a negative 1. So the leading coefficient here is positive 2. The one in the very front on the far left. 3 more. All right, number 10. I've got a 7 and an 8. So the biggest exponent is an 8, so I'm going to put that whole term first. And then 7 is the smallest. That's positive 2x to the 7th. So this is in standard form, and my leading coefficient is negative 1. Number 11, I've got x, x to the 4th, 2, and x squared. So I want to put the biggest degree first. So 5x to the 4th. And then out of 1, 2, and 0, 2 is next, so that's negative x squared. And then out of 3x and negative 2, 3x is next, so positive 3x. And then this plain number with no variable goes on the end. All right, and so now it's in order, 4, 2, 1, 0 for the degrees. And the number in the very front, the leading coefficient, is 5. Last problem, number 12. We have x to the 4th, x to the 5th, 3. So negative 4x to the 5th is the highest degree term, so we use that. And then we have negative 2x to the 4th. And then we've got plus x. And then the plain number always goes at the very end, so plus 3. So 5, 4, 1, 0. They're in order, standard form, and then the leading coefficient is -4. All right, hopefully that's making sense to you guys. If you have any questions on any of that, let me know, and stay tuned for part 2 of this lesson.